Thanks for coming. Today we'll do a summary of our week 1 for our numerical analysis class, the numerical arrow. So the question is how to store a real number in a computer. In math, there are infinitely many numbers in a real line, but for any real number, it can have infinitely many digits, and it can be a non-repeating decimal, such as e and pi. So in our computer only has finite memory, so we can only store finite many numbers with finite many digits. So how do we store this number? This is the floating point number system. So in our computer, it is using the binary system x, which means that any number is represented as the summation of the powers of 2. So we are using this floating number plus or minus 0.1 xxx times a power of 2. In the 32-digit number, we have 1 sign bit and 23 plus 1, the 1 for the first one here after the decimal. Mantissa bits and 8 exponent bits, which means that R ranges from 0 to 255. We also have the 64-digit number system, which is more accurate, but is also more computational expensive. Since we are using the floating point number to replace or to store real numbers, there could be arrows in x minus tilde x if we denote the floating point number by tilde x. In the 32-digit system, the round-off arrow is 2 to minus 25 times 2 to the power r minus 123 for x, which equals to 0.1 xxx times 2 to the power r minus 123. In numerical analysis, we more often care about the relative arrow, which is x minus x tilde takes the absolute value divided by x, the absolute value of x, which is more or equal than 2 to the power t plus 1. So t is 23 here. How many digits we use in the Mantissa, in the Mantissa digits? Suppose we have a function and a real number that we wish to evaluate f of x on our computer. Ideally, we get f of x, but in fact, we get tilde f x tilde. So first, we need to store x as tilde x, then we evaluate f of tilde x, and then we store f of tilde x as tilde f tilde x. So that is f of x plus epsilon f tilde x. So how do we evaluate the arrow? Because we have no control of epsilon f, that's machine accuracy, we take a look at the first term f of x plus tilde x. Using Taylor expansion, it can be approximated by f of x plus x times the derivative of f at x times epsilon of x divided by x. So that's the relative arrow for x. We define this term x times f of x divided by f to be the condition number cf. In other words, tilde f x plus epsilon x minus f divided by f can be approximated by cf times the relative arrow in x plus the relative arrow in f. So cf is also called the amplification factor. Thanks for listening, and here's one final special note. So in the 32-digit floating number system, the machine accuracy or the relative error is 10 to minus 6, and in the 64-digit system is 10 to minus 32. So we need to avoid calculation that involves two numbers whose magnitudes differ too much to avoid loss of information. For instance, if we are using the 32-digit system, then probably 10 to 8 minus 1 will give us 10 to 8. So we lose the information of this minus 1. So in numerical analysis, we more often talk about the relative arrow rather than the absolute arrow. Thanks for listening.